Hello everyone, it's me Murli. By now you might have heard about Microsoft Fabric. This video is about the part 1 of data engineering for beginners on the end-to-end analytics solution Microsoft Fabric. Okay, so once after you log in onto the Microsoft Fabric, this is how the first page looks like. You may need to take the Microsoft Fabric trial license to log in here. So once after you log in, you see all the products which are offered by Microsoft Fabric, and in this we will be mostly focusing on the Synapse data engineering. And the same thing, you can see it here as well. Click on the Microsoft Fabric and you will click on the data engineering. Once after you come into the data engineering space, here everything is divided, means all the Spark pools are in the workspace level. So when you click on this workspace, here you can actually create a new workspace. By default, it has created a new workspace on itself. And if you click on these workspace settings, here you can see on the data engineering side, when you click on the Spark Compute, this is where you see which is a starter pool, which by default it is ready for us to straight away use it with number of nodes as 10, and it has a 1.1 version of runtime with Spark 3.3 and Delta 2.2. so this is Apache Spark and this is a delta.io. With these parameters, a workspace is already available for us, so we will use this existing workspace. When you click on this workspace, here you can actually create all these, whatever you are seeing here. You can create a notebook, you can create a lake house, and all the other features as well. Now, within the Microsoft Fabric, all this data is going to be in one lake, and that is what is this one lake data hub. So within this one lake data hub, you'll have all the lake houses, you'll have data warehouses, etc. You can actually see in my introductory video of how this particular Microsoft Fabric architecture looks like. Now coming back to this my workspace, what I want to do is I want to create a new notebook. So you go here, my workspace, click on the new, and you will click on the notebook. When you click on the notebook, it creates a new notebook for us, something like this. So you can click on add, and you can add one of the lake house here, and you can carry on typing all the Python and PySpark, Spark SQL commands. What I did is I created a notebook ready for us so that I don't waste time in typing each and every command. So, and also I will give this particular notebook in the description below. Now, I clicked on this notebook which I readily created for you. Now, we'll start with this. What we see here in this notebook is, here we got run, and when you first come here, you'll see as stop session. As you have seen here, something. No, I think when you start, then you will see stop session. Okay. So I want to actually use this first cell to start the session. What I did here is I just given a simple example of the Python variables, how we declare the Python variables, and some simple addition, and I'm just printing it. Shift enter, if I say it is connecting, and now it is querying the session status. It is starting the session here, and it is running that particular cell. What you need to understand in this particular notebook is, if you click on this drop down, by default you'll write all our code in the PySpark. If you're experienced in Scala, you can write in Scala. If you are good at SQL, you can write in Spark SQL, and for the people who are used to R, they can use Spark R. But in this total series, we'll be working on the PySpark and the Spark SQL. That's what is our focus. So I executed this in this, and in the next cell, if I want to get this cell, I will click on this code and I will get this new cell like this, and I can start typing here. For now, I already got the new cell. That's why I will just delete that. Now in this new cell, here I've just printed it as C, so you got value as 30, and here I formatted that print like with a string, a formatted string. What we are trying to show here is whatever the variables are there, A, B and C, I can use them here in the F double quotes. Those variables can be put in enclosed in the curly braces like this, and you can execute this, shift enter. So you get this output, sum of 10 and 20 is 30. And if you want to see what is the type of a variable, just you say print type C, and it is showing it as an integer. In the same way, if you want to declare a string variable, we'll be declaring a simple string variable, and you can just print it. And this is how you will get the type. And what we are trying to see here in the beginner's course is a very simple declaration of Python variables, some if condition, for loops, which is bare minimum necessary for us to start the PySpark and the data engineering work. So offline, because this focus is all on the PySpark data engineering, we'll not be paying much attention of in-depth concepts of Python. If you want to actually go for in-depth concepts of Python, this is not the video for that. Okay. Now, here's a simple example for if condition. I declared a variable and I am actually checking if that particular variable is an even number or odd number. And I used the mod operator, something like this, and a mod 2, if it is equal to 0, is the even. Otherwise, if I actually change it to some 50, and if I run this one, it knows that a mod 2 is equal to 1, because the remainder will be 1 and it is a odd number. So this is a if condition. This is how we will be using if, like this, colon, and we give a tab to have a indent here like this. Right? Now next, a for loop. Then in the for loop, I for as iterative variable in range 10, 20, and I'm just printing I. And how range works? Range begins with this value, ends with the final value minus that incremental value. Here in this, the default increment is 1. So 20 minus 1 is 19. So it goes from 10, 11, 12 up to 19, something like this. This is how the range operator works. So we have seen till now if condition and for loop. Now let us go to the next thing called a complex type within the Python is lists. It's like arrays in other programming languages, but here in Python we call this as lists. I got a list of values, some 4 values in strings, and I'm calling it as products. So I run this one, and the type of that products is list. If I want to print that list, print products, and I get here like this. If I want to iterate through that list, I will simply use a for loop, and this for loop iterates and prints that output. Now what I want to do is, whatever this list data is there, I want to read that list, convert that list into a PySpark data frame. So what is a data frame? So data frame means it is you can think it as a table, but it is in the memory, in the temporary area. So this is all in the memory. So when you give this list and use the spark.create data frame with data is equal to, data is the first parameter, and I want to pass this list. Schema is equal to string type because the content is all string, and I run this one. So in the next line number 7, I said that particular data frame dot print schema, which prints the schema like this, root value, and it is a string value, and I'm using this data frame dot create or replace temp view, and I'm just creating a temporary view on top of the data frame. So what is the advantage of this temporary view? I will show in the next cell, in the subsequent cells. So here I'm just printing that particular data frame, df product set, and observe this. Now you got this output in a data frame, and see this here, it is giving the column heading as value because we are not specifying what that column means, whether it is a product name or product description. We are not specifying that in this example. So how to specify it? Now let us go to the, I will show you in the next subsequent sessions, but here observe this. Whatever the temporary view I created on top of a data frame, I can use %SQL magic command and say select star from product set temp view. And when you say %SQL, automatically this converts to the Spark SQL. And when I run this, it gets the output like this. So this is an alternative version of display. So display data frame or select star from that particular temporary view. So that's how you can get this output. Next, this is the next example of within a list, within a Python list, if we have a tuple, tuple means a row like this. This is one row, this is another row, this is another row, and this is the other one. Now we got 4 rows as tuples in a Python list. I have defined here the structure of that particular tuple like this. The first one is the product ID. The second one is the product name. So I used, because the product ID, because I put them in double quotes, I'm using it as string type. And product name, I'm using it as string type to begin with. Then these particular struct type and struct field are part of these libraries. That's the reason we have to use this from and these libraries. And then if you use the same technique as before, like this is the data set and this is the schema, and I'm using the data set here and I'm using the schema here. I'm calling it as df product set 1, means it is a data frame name. I'm printing the schema of the data frame and I'm creating it as a temporary view. When I run this one, you get this schema, print schema, and I got this temporary view. I say here display. So I got this product ID, product name as heading. In the previous example, we are not having any heading. Now we are having the column headings like this. And these 2 column headings with the string data types. I will run here the temporary view with select star from product set 1 temporary view, and I got this output. If you want to take this output into your CSV, click here and just click on CSV. When you click on the CSV, it generates that CSV file. Now this is an example here how to load a CSV file into a PySpark data frame. I will try to give you all these CSV files which I have used here in the description link below. But for now, what I have done here is, if you click on this Lakehouse Explorer, and just a second, please bear with me. When you click on the files, inbound, and here we are working on df_product, and product as one example. Let me go back, sorry. Yeah, okay. Here in the inbound, in the product, if I click on the product here, I uploaded one file here into the product. So how to upload a file into the Delta Lake is, if you go into the workspace, if you go into the workspaces, here my workspace, you look for your Lakehouse, click on the Lakehouse, and you can see here the Lakehouse like this. I created a folder called inbound. In this, I created another folder called product, and I have uploaded here. So you can upload the files, what all the files you want, you can upload them here in this way, right? Yeah, upload files. So these are the files. Now I am using these files here in my example. Let me take you back there. Yeah. So you understood where I am uploading the files now. I run this. Here I got spark.read format CSV, which means it reads the CSV file, and it comes, the output is read into a data frame, and I am displaying the data frame. When you display the data frame, observe this particular CSV has the product ID, product category ID, product name, but we haven't specified any options here that this particular CSV file has a header and it is having so and so data types for each columns. We haven't specified anything. If you just specify CSV, it reads, but it may not be helpful for us. That's why in our next example here, what we do is we read it, but in the options, header is equal to true, and we even specify the delimiter as the comma. By default, the commas is the delimiter in a CSV file. So I run this one, and we get this output, proper headers, and this is how you get. In this example, what we do is we extend this with the schema as well, and with what all the options we have in a CSV file. This is again, you can specify your own path. Don't use the same path what I have used. You just go to your file name and right click, copy ABFS path. So you use that path in here. These are all the different parameters which you can set for each for loading a CSV file. And I have specified a schema of that CSV file, which means it contains the product ID, product category ID, they both are integer types, and a product name, which is a string type. Then I used all these parameters here in this way in the options of all this. I use the schema here, dot schema, and this. When I do this and run, Yeah, now we got the data frame ready. I display the data frame. So we got a data frame. The same data frame. Now let us see the schema. I will create a temporary view like I did before. Temporary view, and then here I use the temporary view to run it in a Spark SQL. So this is how you get. If you want to see the count of rows in the data frame, you can say df_product.count. It has 242 products, and you can use the select count of star from product temp view as well. So either way you can use. This sort of programming is mostly used by the experienced Python data engineers while they were working on the pandas and all. So either you can write your code in this way, or if the person who has experience on the SQL, you can even write in this way. And from the performance wise, they both perform in the very similar fashion. You don't see any difference whether you write it here like this or like this, because the Spark has given the convenience for the developers with various backgrounds. They might have come from the Python data engineering using the pandas data frames, or they might have worked on various databases writing lots of select statements. You got this output. Then in this example we go a bit further, like we got a temporary view, but I want to enhance that temporary view having some current timestamp value as another column, something like this. So what I do, I declare some of the Python variable to capture the current timestamp, and observe this, I am specifically using a format as %y, %m, %e, and y is caps, and h, which is for 24 hours, is %m is for minutes, %s is for seconds. So this is the format, how it is a default format to have which Spark can understand it to convert into timestamp automatically when you use the cast. So I run this. So you got the current timestamp, and it created a data frame. When you run the data frame now, the product enhanced temp view, you can see that record created timestamp. So this is how it comes. Okay. Now what we will see in the next few cells is how to write different types of select statements, and I'll give the example of how the pandas experienced Python developer runs it using the data frame commands, and the SQL experienced developer how they run the select statements. I will show you both the versions. Now this example is how to get the distinct values of a column. Here in this case, the product category ID, and I am using .distinct, something like this, and I will display that. So you get the output like this, and then the same distinct can be used in a select statement like this. Select distinct of the column name from this. This is distinct and order by class. So this is how if you write it in a data frame programming way, it is going to be something like this. Display. So it is all in the sorted order now, the product category ID. And here, the same thing, you say select distinct of that particular column name, and you say order by on that column name, so that you get this output in the sorted order. Yeah. And if you want to do a descending order, then we specify dot descending. So for specifying that columns descending, I'm using a function called column and the particular product category ID in brackets dot DESC. So when I specify like this, you get the output in a descending order in this way. By default, in the above query, you have seen it as ascending order, and here this is a descending order. The same query, if you want to write it in a Spark SQL, you will say order by that column name with the descending order. It comes something like this, the descending order. Then we will go to how we can write the filter conditions in the select statements. In this, I'm just using that from product temp view, whatever the temp view which we created before. I'm recreating it just in case. You got it. And then here I'm using a where condition where the product category ID is equal to 2, which means I want in this complete list, wherever the product category ID is 2, I want only those rows. So I run this and I get only the rows of product category ID 2. You just need to use dot where in brackets, this is the column, is equal to 2. The same thing we can even use with dot filter as well in this way. So you get dot filter, product category ID is equal to 2. So this is how you get this output. The same thing, you can use that in a select statement, product category ID is equal to 2. And I want to use some other conditions as well, between and operator also in the where condition. And I want to get the product IDs which are between 20 and 25. So I run this between 20 and 25. This is how we get. And I didn't sort this one. If you want to sort this, you can say order by product ID. So you get something like this. And always the between and is inclusive of those two values, those 20 and 25. And this is a like operator. If you want to get within this product category 2, I want to display all the products which are the product names are starting with L. So I run this. Here in this top you can see these are lemons and limes. So that's why you get only those two rows as output. So these are the different examples I'm trying to give you, and you may be using any of these examples in your real-time projects. And if you want to see a product name which is starting with capital B, ending with small s, lowercase s, you run this one. Capital B and lowercase s. This is how you get. Then we move on to collect. Till now, the above commands, whatever you executed, they all execute on the entire cluster. Like all the workers in the cluster helps to run these outputs, run these queries in parallel. But when you use this collect, what it is trying to do is it runs and then collects that output onto the driver node of the Spark cluster. So what does that mean is when the data comes into the driver node, there will be only one driver node for the Spark cluster and all the data comes there. So we have to be careful when we are using the collect. It has to be a smaller volume when you are getting this, when you are using this collect. So that we don't actually clog the driver node. So I got this and I just printed that particular df product 2, and this is how you see this output. And if you want to print it, iterate through that particular data output, the collect, whatever this output is there, you want to iterate it and you want to print them, you say p dot that particular column ID, product ID, p dot product category ID, p dot product name, and p dot record created timestamp. And this is how you get this. So basically you got the whatever is there in the Spark data frame, you are getting those values into a Python list, and in the Python list you are looping it and you are showing this output. Then this is another example, like where product category ID is equal to 2, and I want to take, instead of collect, I want to take of 5, means only 5 top rows I want. When you run this, it gives you only top 5 rows like this within this filter condition. Yeah. Now we will move on to the Python function example. Previously we have seen how to load a CSV file, but I want to use that same piece of code and pass it as a parameter. Previously I have given here as a file name, a hard-coded file name, but I defined all this small piece of code in a function called load CSV file, and this is my input parameter, the source path, and colon, and everything after that up to here, and I am returning the data frame. Up to there, all this is in a function, and this function returns that data frame. Because the reason why I'm using this function is I want to load multiple files, and I don't want to write the same piece of code again and again for multiple files. So I declared that function, I'm using that function load CSV file. Here I got one addresses file, I got a stores file, and I got orders file. I'll run this now. I'm creating 3 different data frames. I'm creating 3 different temporary views like this. It has run. I think it is still running. I got a lot of data for df underscore orders, like if you see my another series called data preparation for the production grade example on the Microsoft Fabric. If you just see that series of videos, you will understand how big the data volume I have created for the orders. This is a very big data set which I created, and the orders has millions and millions, hundreds of millions of rows. Now it is getting the data, it is reading all the data into the data frame now. Once after it comes into the data frame, I want to show you the output, how it looks like. Just please bear with me. And observe the one thing, here and here are given the file name, specific file names, but here for orders I have not given any file name. The reason why I haven't given any file name there is, in the orders, if you observe this, it has a daily file from 2023-02-01 like this for 3 months. So daily files like this we got up to 2023-04-30, and each file is having varied sizes. Some are 245 MB, some are 16 MB, 2 MB, 1 MB. Okay, so these are the different file sizes what we have. Now we'll come back to this. Now this particular thing is ready. All the data is now ready for our example. So df_orders, print schema, and this order stem view, let us see how many rows it has. Yes, let me take this one. I'll run this one. While this is running, let me show you what I have got it ready here for you. So in this one, I am actually grouping. I'm using a group by function, and I want to slowly introduce you to the group by function here. Like what I am trying to do here is, here I got the particular data frame df_orders, and I'm using group by on that store ID. So here you observe this, it has how much? This is 136 million rows. Now here in these df orders, I'm grouping on store ID. I want to sum the total price, and I'm giving the column headings, column aliases for this store ID as store space ID, and for sum of total price, I want to give it as sum of sales, and I want to order that output by using the order ID, that particular alias. Because it is taking around, previously I executed it, it took around 35 seconds. That's why I don't want to keep waiting here. I already run this, and this is how you get this output. For each store ID, you get the sum of sales. You can actually run this and see how it comes on your system. But here it took around 35 seconds for me. Then the same query, whatever was written in a data frame coding way, I have rewritten that in a Spark SQL, and this is how it runs. This is how we write. We use the store ID. Observe this, the store ID as a column alias. I am using that single quote which is a slanting like this. On the keyboard, it depends on the keyboard which you are using, but it will be left side of your keyboard somewhere. So I've given this as one alias, and this is another alias, store space ID, sum of sales, like this. Then I want to join the two data frames, like the store addresses and the addresses and the stores, and I want to make it as another data frame called df store addresses. So how to use the joins is like this. Df addresses, which is one of the data frame which we created above, I am joining that with df stores, and here is a join condition like df addresses of address ID and df stores of address ID. When I join them together, I get the this particular data frame. And here observe this, I am dropping this particular column address ID. The reason why I am dropping this column is I get this address ID column from df addresses and as well as df stores. The same column, it will be displayed twice. Instead of displaying it twice, I am just dropping the column of from df stores so that we get this address ID from the df addresses. So this is how it is in this way. And we got these stores. These are the different store IDs which are in different cities and states in United States of America. Now, whatever the DF store addresses is there, I want to join again with DF's orders, the data frame orders on the store ID like this, and I drop the column store ID from the DF orders. I got DF store wise sales, something like this. In this, observe this, up to store ID we have seen previously, and we got all these orders as well in this way. Then the same command, whatever we executed in the data frame way, I have written that in the Spark SQL. I use the addresses, stores, temp view. I join them on the addresses temp view. I got an alias of A. For stores temp view, I got an alias, table alias as yes. And I said here A.address ID is equal to S.address ID. And then again, I want to join on the orders temp view with an alias of O. Here S.store ID is equal to O.store ID. I have displayed here what all the columns which are required from address, from store, and from orders. Then you get this output. Address ID, address line ID, like this. Okay, the same output as before. Now, the next one is I want to do some grouping. I did some joins. Now I am doing summation as well. So I did some sum on that state. I want to get statewise sum of sales. This is how I write using a data frame way. And you get this output, the state, sum of sales in this. Observe this, I use something called with column renamed. This sum of total price, I want to rename that as sum of sales, something like this. The same data frame, I write it in a select statement in this way. Select A.state, sum of total price as sum of sales, and I have given this alias here, and I have joined addresses here, stores on the address IDs, then join to orders on the store ID, and this is how the output is. So this is the combination of the features of joins, group buys, and order buys. Okay, so this is how you get. Then this is another example. I'm grouping on the calendar month and the order created date. So this is daily sales count. This is another example of daily sales count. I use the example of daily sales count and extend it to demonstrate the windowing functions. There are a lot of windowing functions. If you go to Apache Spark, Apache Spark web page, you can find windowing functions in the Apache Spark web page. And I have given a couple of examples here, lag and lead. And there are other windowing functions as rank, dense rank, row num, and you can do the cumulative sums, cumulative averages, lots of other functions, windowing functions are there. First, last, something like that. Okay. give a try. But here, observe what is happening here. And also we are seeing here another concept of inline view. Whatever this select statement is there, previously we got it. If you just put it in a bracket and use a from class above, then this total thing will become a inline view. I just say select these columns, the calendar month, order created date, and this is the column which I derived it like this. A lag of that column over partition by calendar months means in this partitioned column of calendar month, order by the in this order, sorted order of order created date. If I don't specify DESE, which means it is ascending order, as previous day sum of sales. So if I run this one, what you see here is these are the columns which you got in the from the internal query, like calendar month, calendar date, and sum of sales. And this previous day sum of sales is derived based on that lag windowing function. And observe this. In the lag windowing function, the very first one, it is null, and the previous row's sum of sales has come into this row. So when you get the previous row's sales here, then it will help us to do day by day change percentage or day by day percentage of sales. That sort of calculations are very easy for us because we got the current day sales and the previous day sales. So we can use the row level functions to apply to find whatever the percentage of increase or decrease the sales happened for each day. So in that example, this helps. So here this demonstrates lag means the previous row value comes here into the next row based on the partition key. And here this is another example called lead. So in this lead, what happens? The next day's data, it comes into the here. I cannot give you just on top of my head a very good example of lead where we will be using, but surely there are numerous scenarios where we can use lead windowing function as well. So here the next row's data, it comes here to the top row. Next row data comes to this top row. So this is how we use the windowing functions. And then the set operators. So what these set operators? You might have seen in mathematics, union, intersect, minus. The similar set operators are here in the select statements as well. Union all means the query of the top, the output of the top query and the output of the bottom query, they are shown as it is like this, and I am sorting that on the order by 1. 1 means the first column. And when we are using the set operators, the most important thing what you need to remember is the corresponding columns, the state and state, they should be, first of all, the corresponding number of columns should be same number. If we use 5 columns here, you should be using 5 columns here. They should be of the same data type so that you get the output correctly. Then when you say union all and order by 1, you see you got Alabama and 2 times. Why we got 2 times? Because when you execute this, the top one, you got Alabama, and the bottom one, again you got Alabama. That's the reason you are seeing here the states which have come multiple times, you see multiple values like this. That is what union all means. Means it will not give us a distinct of the state output on the combination of these two. It just gets the output of the top query, output of the bottom query. Then if you come to the union, this is very similar to the top one, but it gives you the distinct value of the states. So this top query, union, the bottom query, order by 1. So you see here you get Alabama, Alaska, something like this. Yeah, only one state value. Then the intersect, which means it gives you the common states of the top query and the bottom query, which are common in both. When you execute that, these are all the common states which are in both. Then comes the minus. What is this minus? The first query minus the first query output minus the second query output means if there are states here which are not here, then only you see them in the output. So in this example, this is A minus B, which are here, but they should not be here. In this output, there are 5 states like Rhode Island, South Carolina, like this, which are in the first data set, but they are not there in the second data set. That's why you got those 5 rows as the output. Then I reverse that same queries in this way, B minus A. So this day's data like 2023-0202 minus 2023-02 minus 01. So when I do this, then what happens? It has shown no data available, which means you are not having any other states which are, means all the states which are here are even here as well. That's why you got no data available. I hope you got the differences between union all, union, intersect, and the minus. Now, A union B is equal to B union A. A union all B is equal to B union all A. A intersect B is equal to B intersect A. But A minus B is not equal to B minus A. That's what you need to remember. This is the same mathematical functions, how it works. In the same way, it also these outputs also comes in that way. Then we will actually understand some extended versions of joins. In the above queries, we have run lots of joins using equi-join. And I want to demonstrate here what is left join, right join, full outer join. For that, I have taken a simple example, small data set, so that you can clearly understand the difference between all these different 4 versions of joins. I've taken some 4 products of Microsoft Fabric in the dataset 1, data 1 Python list, and I'm converting that into a Python PySpark data frame. And I got another data set, and observe this. In this data set, we got 101, 102, 103, 104. In this data set, we got 103, 104, 105, 106. Here 105, 106 is not here. 101, 102, which is here, is not here. Purposefully I took in that way, and I want to show you how, when you have the data sets like this, how it works with this equi-join, left join, right join, and the full outer join. Now I got these 2 data sets. I did a join between those 2 data sets. When I say a join, a equi-join, whenever both the product IDs matches, then only you get. So here both the product IDs matched, that's why you got this output. Then in this example, I used left join, which means display all the products at the data set which is there in this particular data frame, and then whatever is joined, just show all those joined ones. Rest all will be null, just like how it is shown here. You display all these rows of this first data set, left join with this one, and this is how it is. Left join means this left to this. Okay, so whatever is in the left side, if you put something like this between these 2, this is left, right? So that's what it means. Whatever is there in the left, get me all that list of products, and wherever there is a join, just join them, and others will be null, something like this. And then this is a right join, which means this, so between these two, the right, which is this. Get me all the rows of this, and wherever there is a match with this one, get those matched ones, others will be null. So this is how you got all the rows from PS2, and this is the output from PS1. And then the full outer join. So what is this full outer join? Wherever it joins, we get 103, 103. It gets the output like this. Wherever it is there in the left data set but not in the right data set, it will be null in the right data set. Left, you get it. Wherever null in the left data set and it is available in the right data set, it comes something like this. And if I want to get the product ID, because here you see some product IDs are there and some are null. Some are null and we got some product IDs. So I use a function called colis, and in this colis I get the product ID one, product one from the first data set, and product ID from the second data set. So you get the sequence of numbers something like this, 101, 102. So in this, whatever the first, what is colis? Colis means in that list of order, wherever the first value is found, a non-null value is found, display that. So in this example, in these two, this is the first non-null value, so it displays. So in these two, in these examples, this is null and this is the first non-null value, so it displays this. So this is how we get all the full outer join. And there are lots of Spark SQL functions where you can give a try. You look for Spark SQL functions. Go for this. Here, there are lots of functions and you can try all these functions, how they work. If just it's as simple as if you want to try something as, let us say, some date add. They have some example here, date add. You copy this and get to your notebook and run that. To understand how each function can be used. Here it is, they're adding this particular to this date, they're adding 1, so you get that output here like this. I leave it to you to explore all these different functions of Spark. It's a very good learning. I will try to close this session now and we'll again catch up in the part 2 of it, where we'll see how to store this particular data frame data into the Delta Lake tables. That's where we persist the data and we understand how to write various Delta commands as well. Thank you so much for your time, and we'll catch up in the next session. Thanks. Bye.